Hello guys, we have already learned about the destruction of the statement. So now for the implication or conditional of the statement. A compound statement of the form if P then Q, if P then Q is called an implication of the statement. Here P is called hypothesis or thesis or antecedent, and Q is called the conclusion or consequent. Here if clause represent P, then clause represent Q, that is P is sufficient for Q, Q is necessary for P. If then you can understand it, P is sufficient for Q and then Q is necessary for P. Now the three tuple. Now let's move to the example of this. If 3 is less than 0, then 2 square is equals to 5, which will be true. First of all, let's gain some knowledge about the truth table, that is P, Q, and we represent implication or conditional of the statement, as I've already told you, by symbolizing this, symbol this, if then Q. This we call the implication or conditional statement. This is P, Q, true, true, false, false, true, false, true, false. The truth table will be true, 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 false, 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 true, true, false, false, true. This is our exception case, guys. Focus on this. This is our truth table for the implication of the statement. Then this is for now. Here, if 3 is less than 0, that is false. As a real system, 3 is not less than 0, and 2 square is not equals to 5. This is the square is equals to 5 is false. Then false is equals to true. Similarly, we can give another example as if 3 is prime, then 2 is greater than 1. Here both statements are true. Here both statements are true, true. Then it gives the true value. I hope you understand it. Let's move to the another topic. Before going to the next topic, please let's understand what is the negation of the conditional. The negation, we have that I have already told that negation is means the not, that we symbolize as this. Then negation of the P implication Q, that is P implication Q, negation of P implication U, Q is this. We symbolize this, that is we can also write it as P, Q, P and Q. Okay, sorry, that we can call it P and not Q. Let's move to our another topic, biconditional statement. We are on the types of the statements on the first chapter of the BSc Physics basic concepts. Let P and Q be two given statement. I have forget to tell about that. Let P and Q be two given statements. Or compound statement. Compound statement is a statement that we combine two or more than two connectives, that is and, or, not, if and only if. Similarly, if P, if and only if Q, P, if and only if Q, or simply P if Q is called equivalence. We can also call it equivalence, or that is or biconditional statement. I have written it in abbreviation. Now let's move to the truth table of this statement. Firstly, we can denote this as P double arrowhead Q, denotation. Now let's move to the truth table, that is P, Q, that is P if and only if Q. True, true, false, false, true, false, true, false. It gives true, 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 false, 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 true, false, 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 true. It is only true when both of the statements are same kind, that is both of the statement are true, then it is true. Both of the statement are false, then it is false. We can give you example as if 3 is prime, as earlier, 2 is greater than 1. There, both this is true and this is also true, so the value is also true. Okay, this is the example of this one. Negation of the negation, we can denote the negation of the biconditionals statement as this is our negation of the biconditional statement, that we can written also as P biconditionals Q not P biconditionals Q. You can written this as this. Hey, and now let's now we have another topic, that is connectives, that is conjugate conditionals. I will write about this. Let's move to how to know about the conjugate conditionals. If we have two given statement P and Q, then P implication Q is a conditionals. This is important. We need to get knowledge about this. All the questions are from this conjugate conditionals. For Nepal, the statement Q, the statement I have written in full. The statement Q implication P is called converse of converse. That is, we converse the values P and Q from both sides. Now let's move with our another statement. The statement first written as P inverse of P implication Q. This is the inverse of P implication Q. And our another conditional is the statement is called contrapositive of conditional statement. This is our for conjugate conditionals. We need to get knowledge of this contrapositive and converse. This is our most important in this topic. Now let's move to the another topic, tautology and contradiction. This is also important. A compound statement, this is called a tautology if it is true for any set of given statement. If it is true for any set of given statement, and it is a contradiction. It is if false for any set of statement, given statement. Example could be P or negation of P is tautology. I will make it truth table also. P and Q, P is contrapositive. I will make that truth table. This is our now I have made the truth table for this. I will try this. True, negation of the true is false. True, negation of the true is false. False, true, false, true. And we know that is this symbolize or. We can remember as sum or. We do sum when we do or. That is just for symbolization, just for to get knowledge, just for as a prediction. True when any of the value is true. True when any of the value is true. If only one is true, then it is true. If both of them are true, then it will all be also true. Then true, false, true, true, false, true, false, true, true, false, true, true. Any of the value is true. Then this symbolized as and, this is symbolized as and. Okay, then true only when both values are same. True only when both values are same. Here true, false, not same, true, false, not same, false, true, not same, false, true, not same. So this all becomes false, this all becomes true. This is tautology if true. Tautology TT, just remember this, TT, true tautology, false contrapositive. Oh, sorry, contrapositive. Okay, this is much for today. Now we will go through some examples, and we have the proving method of the logical statement. We have the proving methods of the logical statement as a mathematical induction method, as direct method, as contrapositive method. I will tell all these things in upcoming lectures. Stay tuned, guys. Good night.